Okay, so, well, I hope that everybody is having a good day. So remember, tomorrow I am not going to see you because we have another round of testing, and tomorrow afternoon is going to be periods 5 through 8. So I'm not going to see you again until Friday. So the plan for today is we're going to wrap up the properties of logarithms today. I'll go ahead, and in fact, before you leave today, I'll go ahead and give you that assignment. I should have had that out. I apologize. I'm really excited about that. But on Friday, we'll go ahead. I'll pass back the quizzes. We'll go ahead and talk about any questions you might have. We'll go ahead and take a quick look at the next lesson, and then we'll finish out the week with another SEL. Do you realize that once this week is over, we got 6 weeks of school left? That is it. It is coming down to the wire. It's getting close. Okay, so let's take a look. So this is the set of notes we've been looking at for the past couple of days. So we started introducing properties of logarithms. Okay, so the product property says that if I'm multiplying items in the argument, now remember when I say argument, we're talking about the parentheses of the log. I can take those individual terms and I can separate them through addition. Each term gets its own log of the same base that you had. If you're dividing inside of a logarithm, okay, the arguments, this right here is called the quotient property. You can separate those terms, the numerator and denominator, by subtraction. Very important, the numerator does have to go first. Order does matter there. And of course, the numerator and denominator, they each get their own log of the same base. And then we've got the power property. So if I have an argument, some item in the parentheses that contains a power, I can pull that power to the front where it becomes a what? Coefficient. There we go. And remember, these rules are reversible. I can expand or I can condense log expressions. Okay, so I want to say yesterday we went through these last ones here. Let's go back and do a couple of the ones that we didn't do. So we did 26, right? Okay, so let's go ahead and try 24, because I don't think we worked that one, correct? Okay, let's try 24. So just more practice with these properties here. So I've got 1/3 times the quantity log base 5 of 8 plus log base 5 of 27, and then minus log base 5 of 3. Okay, now I can go ahead and try to simplify the parentheses, or I can go ahead and deal with the 1/3. I think it might not be a bad idea to just distribute the 1/3. So then I'm going to have 1/3 log base 5 of 8 plus 1/3 log base 5 of 27, and then this will be minus log base 5 of 3. Okay, and it's super important. You'll notice if I'm going to multiply anything against the log, it's times the log itself. It's not times what's in the argument. So that's why I don't have 1/3 times 8. I got 1/3 times the log. Okay, but see, by doing this step here, by distributing, now I can use what property? Because I have coefficients. Remember, I can take a coefficient and I can do what with it? In a manner of speaking, I can apply it to the argument of that log. Now remember, we're not multiplying, we apply it as a power. So I can do the same thing right here. Now remember, if we go ahead and raise anything to the 1/3 power, that's equivalent to doing what? The cube root. Okay, so instead of rewriting this again, what is the cube root of 8? 2. So I'm going to have log base 5 of 2 plus, now let's do the same thing. What's 27 to the 1/3, the cube root of 27? 3. 3 times 3 times 3. So log base 5 of 3, and then minus log base 5 of 3. Okay. Now, normally we'd go ahead and condense these. Remember, if 2 logs of the same base are separated by addition, we would multiply those. If they are separated by subtraction, then we go ahead and divide them. But here, I actually already have my answer. Does anybody see why? Yeah, log base 5 of 3 minus log base 5 of 3. I've got a log subtracting the exact same log, so those are just going to cancel. There you go. Now, what if I had condensed them using the properties? Would I have still gotten the same answer? Absolutely. Would anybody want to see that? We're okay. All right. Well, let's take a look at number 25. 3 log base 2 of 4 minus log base 2, bless you, of 32. Okay. Now remember, before you condense and pull them together into a single log, I've got to take care of my coefficients. So I'm going to take this 3 right here, and I'm going to apply it to the 4. So somebody help me out. I need log base 2. What's 4 cubed? 64. 4 times 4 times 4. So log base 2 of 64 minus, there's nothing in front of that log, so I'm just going to keep it the same, log base 2 of 32. Okay. 2 logs of the same base are separated by subtraction. Serenity, how am I going to pull these together? Am I going to multiply or divide those arguments? We're going to divide. Now, because the 64 is first, it has to go on top. So log base 2 of 64 over 32, well, that would be log base 2 of 2, because there you go. This is one of those that I can evaluate. Because remember, in one word, what's a log? It's a power. That's all it is. Okay. So basically, this statement right here, I would say 2 raised to what power would give me 2. So yeah, 2 to the first would give me 1. Now, you want to see something really cool? Okay. Of course you do. I mean, that's why you're here, right? I actually didn't have to use the property. Maybe somebody noticed it. If we go back a step, if I took a look at these individually, 2 to what power would give me 64? 6. 2 to the 6th power, so that value is 6. Log base 2 of 32, 2 to what power would give me 32? 5. And what's 6 minus 5? Did anybody notice that we could have done that as well? Okay. So there are different ways to go ahead and work these problems. Okay. Nice, nice, nice. Now we'll move on down here. Okay, let's see. It looks like we did 31. So which ones did we not do? We didn't do 30 and 32? Okay, so let's try 30. Log base 2 of y over z to the 5th squared. Okay, well, the first thing I would do is use an exponent rule. I would apply that 2 to both the numerator and the denominator. So I'm going to end up with log base 2 of y squared over what? Z to the 10th. Remember, when we have a power of a power, we multiply those. Okay. Now, I'm dividing items. Danielle, how am I going to separate these? Am I going to add or subtract? We're going to subtract. So this is going to be log base 2 of y squared minus log base 2 of z to the 10th. Remember, y squared was on top, so it has to be written first. Okay. Is there anything I'm forgetting? There you go, those powers. Remember, we got a power rule. So this 2 and this 10, I can pull those to the front. So my final answer will be 2 times log base 2 of y minus, pull that 10 to the front, log base 2 of z. Here we go. How are we doing? Okay. Does anybody have any questions? Anybody confused? Okay. Because the quiz we have next week, it's going to be over these properties. You'll have to expand, you'll condense, all that good stuff. Okay. Oh, ready to go? All right. Now, 32, I'm going to go ahead and give you the opportunity to try it on your own, but I am going to get you started. That is not what I want. I want to erase this. Okay. So if I have the 4th root of m to the 5th and n squared, okay, so it's been a while, but this is what we were talking about after we came back from Christmas. How would I rewrite this with a fractional power? Does anybody remember? There we go. So here's the thing. This would be the same as saying m to the 5th n squared to the 1/4 power, right? Okay. Now, this problem is starting exactly the same as number 30 did. I've got log base 3 of m to the 5th n squared to the 1/4. That's supposed to be a 4 right there. I can do better. So let me go ahead and give you a few seconds. What I want you to do is expand this as much as you can. Okay. Perfect. Okay, first right answer. Oh, this one we shouldn't evaluate because we don't know M and N. Perfect. I'm the real sheep. Everybody about ready? Can I just go ahead and write the final answer, or would you like me to do it in steps? You write the final answer? Okay. So it should be 5/4 log base 3 of m plus 1/2 log base 3 of m. Where'd the 1/2 come from? See, when I multiply the 2/4, I've simplified that. That's where I got the 1/2. All right. How many folks got that right? Okay, so a few hands are going up. Is there anything I can do to help? Does anybody want me to show the middle step? Yes? Okay. So I'll go ahead and move this down here. So if we're going to go ahead and work with the fact that this is now m to the 5/4 times n to the 1/2. Well, first I'm going to break these apart. I'm going to say log base 3 of m to the 5/4 power. My 4s are looking weird today. All right, sorry. 4, okay. And then plus log base 3 of n to the 1/2. See, all I would need to do now is take those powers, even though they're fractional, pull them to the front. Okay. All right. So this right here, this is kind of a closure. This wraps everything up in the lesson that we were talking about. Okay. We also have a couple of other rules here. Okay. These are basic logarithms, and they're kind of extensions of the rules we talked about. If I have log base b of b, anybody think they know what that is? It's 1. Yeah, because think about it. Remember, what is a log? It's a power. So this base b to the first power will give me that value. Okay, so that makes sense, right? What about this next one? Log base b of 1. 0. Anything to the 0 power will give you 1. Okay, we got some examples here. Well, log base 14 of 14, that's 1. Because 14 to the first power is 14. And then log base 3 of 1, that is 0. Again, because 3 to the 0 power would give me 1. Okay. Now, the product rule. So what do I do if I'm multiplying items in an argument? Add or subtract. So this is going to be log base b of m plus log base b of n. Okay. So let's condense. 2 logs of the same base separated by addition. So I'm going to multiply. So this is going to be log base 5 of what? 42. 6 times 7. So I multiplied those arguments together. Okay. Now, for the expansion, all I need are 2 numbers that would multiply to give me 63. 9 and what? 7. So let's say 9 times 7 is going to be 63. So that would be log base 2 of 9. And then what? Plus log base 2 of 7. There we go. That's all there is to it. Okay. The quotient rule, if we're dividing, we're going to subtract. Remember, with the numerator first. So log base b of m minus log base b of n. So let's try this example. Log base 4 of 84 minus log base 4 of 12. Okay, now, is it 84 over 12 or 12 84s? It's going to be 84 over 12. Now, this divides evenly. So this is going to be log base 4. Does anybody want me to write out the fraction, or is it okay if I just show the simplified version? Okay, it is 7. Lucky number 7. Okay. All right. And then log of 9. So I just need 2 numbers that would divide to give me 9. What's that? 36 and 4? Okay. So let's say 36 divided by 4. So this would be log of 36 minus log of 4. There you go. Anybody who's confused? Anybody lost? Okay. The power rule. So if an item in your argument has a power, we can pull it to the front. So this would be n times the log base b of n. But remember, it's reversible. Okay. So 2 log base 3 of 8, this would actually be log base 3 of 8 squared. And 8 squared, as we know, is 64. Okay. But 3 to a certain power won't immediately give me 64, so we're not going to go decimal on that. We'll just leave it as is. Okay. All right, now expand. It says log base 2 of 6 to the x minus 1. There you go. Even though it's a binomial power, that doesn't change anything. I'm going to pull it to the front. So I'm going to have x minus 1. I would probably put it in parentheses, and then times log base 2 of 6. That's all there is to it. Okay. Okay, we're almost done. Here's our last one. Okay, this goes from a previous lesson, so the other week, change of base formula. So this was log of A over log of B. So here's how this worked, okay? The original argument went in the numerator. The original base went in the denominator, and then you get to choose whatever new base you want. Okay, but remember, there were 2 restrictions. What can C not equal? So C cannot equal 1, and C has to be greater than 0. That means C has to be a positive number. It's got to be positive, and it cannot be 1. Okay. So this one here says we want to go ahead and evaluate the expression below. So log base 7 of 32. So you want base 10. Okay. So let's say base 10. So log base 10 of 32 divided by log base 10 of 7. Okay, remember the original argument, it goes in the numerator. The original base goes in the denominator. And we just randomly chose the common log base 10. Okay, so let's plug it in and see what we actually get. Okay. So we'll come on over here, control divide. Where do I get a log from again? Control 10 to the x. Okay. We go ahead and put those in. So we wanted base 10s, not 1010, even though that would work. Okay. Base 10. And then the top one, I believe, was 32 and the bottom was 7. Okay. So let's see here. 1.78104. So let's just say to 2 decimal places, 1.78. Now, because we rounded, it's not going to be perfect. The more decimal places I take, you know, the closer it's going to be to my value. So let's actually see how close we got. Let's take 7 and let's actually raise it to the 1.78 power. Okay, so 7 to the power of 1.78. Remember, we were shooting for 32. So 31.94, it's pretty close. The more decimals I take, the closer I'm going to get to my actual number. Okay. But is everybody starting? How are we feeling about logarithms? Good? Does anybody have any questions? Okay, we are done. Let me go ahead and get this